this video, we're going to take a look at something called evaluating expressions. But before we jump into that, we want to make sure that we actually know what an expression is. Our whole unit right now is expressions. So what does it mean for something to be an expression? An expression is a math sentence that doesn't have an equal sign in it. That sentence could be very simple. It could just be a number or a variable. It could have some operations in it. But as long as it doesn't have an equal sign in it, that means that it's an expression. We have two different types of expressions. The first would be a numerical expression. And this is an expression that only has numbers and operations in it. There are no variables in a numerical expression. So as soon as we see letters, that means that we are not dealing with a numerical expression. It could have what we call constants, which are just numbers. It could have powers. We could have operations, which would be those different ones that we have, but we can't have any variables. As soon as I introduce variables, then we're dealing with an algebraic expression. Usually when we think about variables, we start to think about algebra, that idea of looking for unknown values. And an algebraic expression could also have numbers, operations, exponents, all that, but it has to have at least one variable. So if we look at our example expression here, I want you to pause the video and answer whether this is an algebraic expression or a numeric expression for this example expression right here. All right, so looking at this, we see that we have these letters here. So this is an algebraic expression. And the first thing that we notice, we have some different vocabulary words here that we're going to talk about. All right, so first we have constant. Constant means no change. And when we look at the name variable, in there we see the word vary, which means to change. So if we have no change, that means we have no variable. So it's a number that's by itself. We're either adding, subtracting it on at the end. So here we have plus 12, that's our constant. And when we think about these terms, I'm going to take that whole sign with it. Positive 12 is my constant. A coefficient is a number that's next to a variable that's tied to it with multiplication. So think about any time we had a number outside of parentheses, that was multiplication. It's the same thing when we have a number next to a variable. When you think about coefficient, you want to think about co means together. So coefficient is a number that goes with a variable. When we take that coefficient, we take that whole term, and we look at the coefficient part of it, just the number. A variable, like we talked about, are those letters or symbols that represent different numbers. So here we have x, and we have y would be another variable. And a term is like a word in our math sentence. So we have negative 3x, we also have 4y, and we also have 12. So it's anything that's linked with multiplication or division, but not a sum or a difference. Plus signs and minus signs are like the spaces between the words in our math sentences. All right, so now, keeping that vocabulary in mind, go ahead and pause the video and see if you can answer some of these questions. All right, so we want to know, what is the coefficient of x? So I go to x, and I look at the number that's right next to it, and that's negative 3. So my coefficient here is negative 3. Next we want y, so I go to y, I look at the coefficient right next to it, and I also have to double check this sign because this is glued to the 6. This is positive, so it's positive 6y. Coefficient of the z, I go to z, I check right next to it, I have a 3, but I also check this sign, this negative and that 3 go together, so that's negative 3. If I want to know the variables, those are all the letters I see, so I see x, y, and z. So those are my variables. The constant in the expression is a number that's by itself without any variables. So I see that that's 12, but then I also have to take the sign that's with it, so it's going to be negative 12. And then lastly, we want to know how many terms there are. So remember that the pluses and minus signs work as spaces in my expression. So we have this whole part, which is a term, then I get to a plus sign, so that's a space. We start over, get to the minus sign, we start over, and get to the minus sign again, we start over. So I have 1, 2, 3, 4 terms in my expression. All right, go ahead, pause the video, and try this one. All right, so if we look at each of these, first we want to know the variables. These are our letters, M, Y, G, and F. Next, we wanted to know the constant. This is the number that's by itself. that on the end here. It's not linked to anything with multiplication or division. That's positive 7. Next, we wanted to know the number of terms. So remember that addition and subtraction separate our terms. So we have our first term, we stop at the minus sign. Second term, stop at the plus sign. Third term, stop at the minus sign. Fourth term, stop at the plus sign. And we've got our fifth term. So altogether we have 5. The coefficient of the m is the number that's right next to the m there, linked to it. See how there's really no space here at all? That means that those are being multiplied together. And then our coefficient of the y, this is one of those invisible math values. This is on the orange sheet inside your notebook. Anytime we don't have a number next to a variable, it's the same thing as having a 1 next to it. So if I just have y, that means 1y. Now I also have this negative sign in front. So that means that the coefficient is negative 1. And the last question wanted to know what is the coefficient of the g, and the coefficient of g is 8. This is where we're going to get into more of the math with the expressions. And we're going to want to evaluate them. Evaluate means find the answer or find the value. But in order to do that, we need to be given replacement values. If you replace something, you take something out and put in something new. So replacement values are the new values that we are going to put in where the variables used to go. We're going to substitute, would be our math word. So if I look at my first example here, if x equals 3 and y equals negative 1, I want to evaluate negative 6xy plus 3. The first step that I'm going to do is rewrite my expression, but instead of the variables, I'm going to write parentheses. So the negative 6 stays the same. The x gets replaced with parentheses. The y gets replaced with parentheses. Plus 3 stays the same. My second step is to go ahead and use my replacement values based on what I'm told. So x equals 3. That means wherever x was, I'm going to put a 3. So x was the first space here, so 3 goes here. Y equals negative 1. So wherever y was, I'm going to take y out and put in negative 1. My last step is to do the order of operations to solve this expression. So remember, we have our order of operations, and we're always going to follow this. So first I look for parentheses. I have parentheses here, but there's no math inside them, so I don't have to do anything there. I move on to exponents. There's no exponents to solve, so I move on to multiplication and division. Remember, this moves left to right. So the first thing I'm going to do is negative 6 times 3. That's negative 18, and I've already used this, so everything else gets copied down exactly the same way. I check for more multiplication or division. I still have that here. So negative 18 times negative 1 is 18 plus 3. Now I'm finished with multiplication and division, and I can move on to addition and subtraction. I add these together, and I get 21 for my final answer. We're going to try the second one as well. We're given a different expression and different replacement values. The first step is to rewrite the problem, except I take out the variables, and I put in my parentheses. So I've rewritten everything exactly the same. Negative 5, instead of x, we've got parentheses. Minus 3, instead of y, we've got parentheses. Then, we're going to go ahead and substitute. So x equals negative 2, so instead of negative 5 times x, we have negative 5 times negative 2. Y equals 5, so instead of 3 times y, we're going to have 3 times 5. And now, I'm going to go through and use my order of operations. So again, we think about what we've got to do. I don't have any math inside my parentheses, so I move on. I don't have any exponents, but I do have multiplication and division, so we move from left to right. I start with the first multiplication that I see. So negative 5 times negative 2 is 10. We write everything else exactly the same. Now, I still have multiplication to do, so I cannot do this subtraction. I'm still in this multiplication division step. So the 10 minus comes down all the same, and now I do 3 times 5. 3 times 5 is 15, and now we're finally done with that multiplication division step. So I can do 10 minus 15, and I get negative 5 for my answer. Go ahead and pause the video and try the example on the left on your own. So we start with that same first step. We pull out our x and our y, and we replace them with parentheses. Then we substitute in our replacement values. X equals 3, so instead of the x, I put in a 3. Y equals -1, so instead of the y, we put in a -1. Then we use the order of operations. There's no math inside the parentheses, so we move on to the next step. We do have some exponents to deal with. So 3 squared is the same thing as 3 times 3. 2 means that we have 2 factors of 3. 3 times 3 is 9. This is multiplication here, so everything else comes down exactly the same. Then we still have another exponent. -1 squared is -1 times -1. That's a positive 1. Everything else stays the same. Now we're into the multiplication division step, again working left to right. The first thing that we see is 2 times 9. Then we also have to do the 3 times 1. Once we're finished with that, then we can add everything together and we get 21. Go ahead and pause the video and try the last example. Alright, so if we look at this one again, we always start the same way. We pull out each of our variables and put in parentheses. Everything else that's in the problem, this negative sign, this plus sign, this exponent, this plus 3, that all stays the same. Then we substitute in our replacement values where the variables used to be. Now we follow the order of operations. There's no math inside the parentheses, so we move on to exponents. -5 squared means that we have 2 factors of -5. So we have -5 times -5, which gives me 25. Then I'm into my multiplication division stage. This part here is actually hidden multiplication. This is the same thing as -1 times -2. Anytime I see that negative sign, whether it's out in front of a variable or out in front of parentheses, it's the same thing as -1. -1 times -2 is +2, and we write everything else exactly the same. Then we still have some multiplying to do. 3 times -2 is -6, and I wrote these parentheses here just so we don't get confused between the plus and the minus sign, but if you didn't include them, that's okay. They don't change anything. Once we finish that, we are finished with our multiplication and division, and we are ready to go into addition and subtraction. You may also see this rewritten as 2 plus 25 minus 6. They're the same thing, both of them are correct. 2 plus 25 is first, so we do 27, then we add the -6, and we get 21 for our answer.